Thank you for joining us today on today's webinar, AI Assurance in Practice and the Theory Assurance by Design. I'm joined here with two experts from Synoptix. We'll be looking into trustworthiness around AI. As we adopt AI more and more into our business practices nowadays, we're looking into the trustworthiness of what AI brings to us. So I'll hand you over now to Sam and Callum from Synoptix. Gentlemen, if you'd like to introduce yourselves.
Yeah, good morning, everybody. So I'm Sam Farrow. I'm the Technology Director in Synoptix. So I've spent the last 20 years dealing with autonomous systems, AI of various different types, and then more latterly in the assurance of AI systems, particularly for high integrity applications.
Hello, I'm Callum Coburn, Senior Technical Innovation Manager at Synoptix. I lead our AI assurance capability, which is all focused, as Sam says, particularly around those applications where it really matters, where there's consequences to that. But importantly, those consequences don't have to be purely kind of safety related or physical consequences, but also reputational, legal, compliance, commercial risks as well.
Thank you, Sam and Callum. Well, look, I mean, why don't we kick off with a question? So I'm quite interested in understanding a little bit more about what does trustworthy AI actually mean, and does it matter?
Yeah, absolutely. So I'll field this one. So the wonderful thing about the concept of trustworthy AI is that it's nicely self-contained and it very much does what it says on the tin. So trustworthy AI is simply AI or an AI system that we've got good reason, justification, evidence to trust for a specific purpose in a specific context. And that's all it is, really. The trick is, how do we do that? And that's why whenever we're talking about trustworthy AI, we always talk about it in the context of another concept, which is AI assurance. And that's simply the process, the mechanism by which we direct, gather, and maintain that evidence that an AI system deserves trust. So the purpose of AI assurance really is to turn trust from an assumption into a justified decision. In terms of why it matters, I think I'd like to pick up on 2 points, and I've got some visual aids for this. The firstly, it's AI adoption. I'm telling nobody on this call anything new by saying that AI adoption is clearly accelerating, it's clearly broadening, but it's also quite obvious that the pattern of adoption is uneven. Most organizations have made the quickest progress, the most rapid adoption in what we'd call easy use cases, low-hanging fruit, low risk productivity tools, AI for supporting drafting of administrative documentation, summarization, general augmentation. The value's there's nothing wrong with that, but the consequences of failure are usually quite limited, and the technology can often be introduced in a way that you don't need to entirely reshape your organization around it. But as we look to move beyond that, and we'll look into some of those more advanced, some of those more complex and potentially consequential applications of AI, embedded decision support and workflow change, or the application of AI in those highly regulated and safety relevant environments, that pace of adoption is much, much slower. And the examples of success and those pockets of excellence are fewer and further between. And that's not because there's no compelling use cases here. In fact, a lot of the most compelling use cases for AI sit in these harder categories. It's often because organizations can't yet demonstrate that the system is trustworthy and dependable enough for use. So I think that's one way in which trustworthy AI and effective AI assurance really matters. It's effectively throttling our ability to adopt AI in many of those areas where it could deliver the greatest benefits. I think the second related way in which it matters is to do with this, what we call the trust calibration problem. So Callum and I and Synoptix more broadly, we work across a range of sectors, a range of clients, a range of applications. And one of the most common recurring patterns we find is that organizations and teams tend to fall in one of two camps. The first is where we trust AI when we shouldn't. If you're anything like me, your news feed will be full of AI horror stories, AI deleting code bases, AI hallucinating legal precedent. But I think if anything, if we've learned nothing actually from the past few years of AI adoption, it's that without a structured way of determining where and why we should trust an AI system, organizations are actually quite poor at recognizing the risks associated with what can seem like quite trivial applications of AI. And I think the Air Canada example is a really good example of this. So some of you may not be aware, but Air Canada introduced an AI chatbot to allow customers to query matters of policy, of bookings, and so on. And one particular customer was given incorrect guidance on policy by the chatbot. They contested that. It ended up in a civil court in Canada, and that court found in favour of the customer. So they essentially found Air Canada liable for the information, for the guidance that chatbot was providing. So that was entirely unexpected from Air Canada's point of view. They had this entire risk, this entire liability that they weren't aware of. So there, what appeared to be a low risk application wasn't low risk at all, and it shouldn't have been trusted. The second camp is the sort of not trusting AI when we should, or at least when we could, if we design and implement the system appropriately. A lot of organizations are hesitant to acquire or deploy AI because they know it's risky, but they don't really know or understand the routes of addressing those risks, the route through to having trust in a system. And I think systemically, the NHS is a good example of this. Nobody would disagree with the sort of the statement that AI has the potential to transform healthcare. But adoption's been relatively slow, and a huge number of really promising systems are stuck in pilot stages, and in part, not in full, but in part, that's because organizations lack that confidence in the evidence, the governance, the controls, in order to scale from pilot to full scale adoption. And I think that's one of the central problems, really, is that trust is often sort of badly calibrated. The challenge isn't that people don't trust AI enough. It's sometimes they trust too readily, sometimes they don't trust enough. But both of these are effectively assurance failures. So AI assurance done well in the service of delivering trustworthy AI, that should really give us the mechanism to both protect our organizations from risk, but also to support and enable that innovation and really unlocking those tougher use cases for AI. So I think, in summary, I think that's why it really matters, and particularly at this point in time.
Great, thank you. And so that, thinking more about and you've covered a couple there, but the high risk stake environments, those environments where you've got high stakes, what are the major risks that we see emerging when AI is used in those areas?
So I think the simple answer is it depends upon the application. I think one of the things, and we'll return to this, I think, later on, is that those risks can be manifold. They are specific to an application, but they also come from unexpected areas. In some of the applications, the risks may be around reputational, they may be around the legal aspects, they may be around the commercial aspects, there may be safety, security. There is a huge different number of facets which may come together to determine whether a system is trustworthy or not, but they really need to be considered on a case-by-case basis.
Okay.
I think one other point just to make here as well is that we're seeing a lot of capability improvement in the frontier models at the minute, and particularly how those are impacting things. That's fundamentally not changing the calculus on this kind of trust calibration problem, though, because there are problems that still persist that have not been solved. For example, big cross-cutting challenges around systems that are autonomous, where they have causal agency and the ability to make change without explicit human oversight. And equally as well about systems that are very generalizable, so they're able to be used in multiple different contexts, and that's a real challenge as well. And even though the models are getting better and better and they're getting more and more capable, some of those fundamental difficulties about the way that they work haven't really changed the calculus in terms of how that stacks up into a business adoption context.
That's great, thank you, Callum. And I suppose we need to focus on where assurance breaks. What activities are happening above waterline and what's happening below waterline. What are the red flags? Where do we see weak assurance?
Yeah, absolutely. And it's probably worth introducing this by saying that it can feel odd to sort of start a discussion around the meat of trustworthy AI and AI assurance by focusing on the negative, where assurance breaks. And we found, however, that in talking to people, talking about these common failure modes, these anti-patterns that we see across sectors, across clients and so on, that can be the quickest way to help them identify those opportunities for improvements in their own businesses. So I've got a few examples here of some of those, like I said, those common failure modes that we see. And as you said, Jed, we have a need here to introduce the concept of sort of above the waterline and below the waterline assurance activities. So Above the waterline activities, that's the things that most of us on this call will be familiar with. It's the assurance work that it's visible, it's familiar, it's often repeatable across projects and across teams. This is where your risk registers, your meeting minutes, your audits, your management systems. So if you've got an ISO 42001 style AI management system, for example, that's where they live. These things they really do matter. But one of the anti-patterns we see is that there's a danger in companies assuming that because a process or because policy exists, that the risk is adequately controlled. I think one of the ways, the analogies we can use to sort of understand why this is risky actually comes from the security domain. So similar to AI, security has ISO 27001 that defines an information security management system. Now, organizations can be certified against this standard, and that management system will come with all the policies, the audits, the governance, the documented controls that you would expect. But in and of itself, this doesn't mean that they're adequately controlling their risk. A good example is Equifax. They had held a ISO 27001 certificate for years when it was attacked in 2017, and that exposed the personal data of, I think it was just shy of 150 million people. The certificate was only actually revoked after the breach, but they've been quite happily getting audited and certified against it every single year. So the presence of that management system wasn't evidence that the underlying risk was being controlled effectively. It was only evidence that process and policy existed. So I think that's the first anti-pattern. We have a process, so the risk is controlled. Organizations become reassured effectively that because we've got governance artifacts, that's evidence that the risk is being controlled and that the AI is trustworthy, and it isn't in and of itself. On the flip side, we've got the, sorry.
No, go ahead. I'll focus on red flags in a second.
No problem. On the flip side, we've got the below the waterline activity. So this is where a lot of the real assurance burden sits. So this is where your robustness testing, your data suitability analysis, adversarial testing, performance monitoring, this is where all of that lives. But in and of itself, this can create a second failure mode. So we've done lots of testing, so the risk must be controlled. But the key question isn't, have we tested it? It's, have we done the right testing? Does it examine the relevant failure modes? Is it actually testing against the things that we care about from an assurance perspective in a representative operational environment? And without a structured approach to AI assurance, this below the waterline activity can become expensive and time consuming very, very quickly. You can be running tests simply because they're available and possible, rather than they answer a defined assurance question. And you end up with a lot of evidence that doesn't really demonstrate anything. So if you can't go into your development teams or into your acquisition teams for AI and say, okay, we are doing this testing, okay, how does that actually contribute to the argument that our system is trustworthy? If they can't give you a clear and cogent answer for that quite quickly, it suggests that something's going wrong in the below the waterline activity here. And I think the key point is that good AI assurance has to connect both of these. It's when one element dominates that you get into trouble. The process and policy without the deep evidence just becomes governance data. The technical activity without structure and purpose and operational relevance just becomes expensive point-in-time testing. AI assurance has to connect both. Visible governance above the waterline and the right technical and operational evidence below it. And another red flag in terms of looking at your organizations is that when you think about the skills and the capabilities that you've got or that you bring in from external help, is that it's important to recognize that the people who can help you with the above the waterline activities aren't necessarily the people that can help you with the below the waterline activities. Governance, legal, compliance, and management system expertise, that can help you establish the right structures. But deeper technical, potentially human factors and operational expertise is really needed to direct and interpret what happens below the waterline.
Interesting. So let's talk good AI insurance. What does good AI assurance look like?
Sorry, I've still got a little bit to go, Jed, sorry. Apologies. The next major sort of common failure mode that we see is that teams fail to approach AI assurance in a holistic enough manner. We all have a proclivity to see a problem through the lens of our own professional biases or through things that we already know how to do, how to measure. A governance expert is going to look for policies, committees, and named accountabilities. A legal expert is going to look at legality and compliance. Technical teams may be preoccupied with performance and robustness testing. These are all valid lenses. These are perfectly valid viewpoints. but they don't necessarily represent a complete and holistic view of AI assurance. And it's in this incompleteness that risk can enter your organization and enter your applications sort of by stealth, if you will. The wheel that you can see on the left-hand side of this diagram here, this is essentially our response to that problem. So it's an attempt to create a sort of a complete breakdown of all the different domains or all the different lenses through which AI application might need to be examined. So for a given AI application, some combination of claims in these domains will be how essentially we define what trustworthiness looks like for us. It's worth noting that different regulatory bodies, different standards bodies, they have their own breakdowns. They're all approaching things from a slightly different angle. All of those breakdowns are different from each other. What we've produced here isn't designed to copy any single one of them, but it's designed to be mappable to all of them. So this is our view of what a complete view of AI trustworthiness looks like and how you can sort of break that down. The really important point here, though, is that not every system needs equal attention in every segment. There are very few AI applications where you need to worry about all of these domains or all of these lenses, or certainly there'll be some that are far higher priority than others, and that will direct essentially where you put your effort. And that leads to sort of two questions that, again, we really should be asking ourselves. And if we're not, then we've possibly got a problem on our hands, which is what matters to you as an organization that's developing or acquiring AI. Do we care that it's reliable? Do we care that it integrates with existing processes? Do we care that it's secure, that it complies with legal frameworks and so on? But also what matters to those affected. So our users, operators, patients in a healthcare setting, what do they care about? You know, they may want to know that the system's fair. They may want an ability to understand the risk that the use of an AI in a workflow brings to them and to be able to opt out. They may care about being able to contest the decision that AI has made on their behalf. So good assurance has to address both of these perspectives. And as I said, the diagram on the left can give us a framework by which we can ask these questions and understand their impact on our approach to AI assurance. So the key red flag here is if you're not approaching things holistically, things can enter your risk can enter your business by stealth. The wheel is there to prevent blind spots, where the two questions on the right are there to prevent us from defining trustworthiness in a naive or in an incomplete way. So unfortunately, we don't have a huge amount of time to go through any more of these anti-patterns in detail. But I did also want to provide you with some of the other key sort of themes that we see where AI assurance fails. So just rattling through these quite quickly. Governance data, we essentially covered that during the above the waterline, below the waterline element of the presentation. Outcome metric mismatch is extremely, it's ubiquitous across a lot of applications. So this is where the measures we use to evaluate an AI improve, but the outcome that we actually care about doesn't, and that's essentially because of a mismatch between what the metric is telling us and what the outcome we actually desire is. A really useful real world example of this is actually a medical example. So it was an AI system that was deployed to screen patients in Thailand, I believe, for diabetic eye disease. Within the lab and in pilots, the model, the metrics demonstrated incredibly strong diagnostic performance. The metrics were off the chart. And if the assurance focused only on sort of that sensitivity and accuracy, it would appear successful and assured. But the outcome that really mattered, what people really wanted from it, is whether more patients could be screened quickly and referred appropriately. And when actually the analysis was done in practice, I think it was more than 20% of the images were rejected because the real clinics couldn't control the lighting, they couldn't control the image quality, there was slow and unreliable internet sort of connection. So actually this massively throttled the ability to achieve that desired outcome, to get more patients through quickly and robustly and referred appropriately. So the model performed well against its technical metric while failing at its outcome metric. And that is an example of something that we see across a range of AI applications, particularly as talking about these benchmarks and these sort of standard metrics is something that our vendors like to speak to us about. That's not necessarily the most important thing for us. I think next is evidence rot. So this is quite simple, is that assurance evidence is only really valid for the system and the context it was produced against. If the AI system changes, the data that the model has been trained on changes, and and that evidence is not maintained alongside those changes, we can end up relying on proof and thinking we're in a good position from an assurance and risk perspective. But that assurance case is describing a system which no longer exists. So what we really need there is a dynamic approach to assurance that can follow a system through life. And again, we often don't see that. I think you've then got supplier opacity. Many AI systems, I would probably say most, we depend on external models, on data sources, on hosting providers, subcontractors. A lot of the time, customers don't necessarily understand where their data is processed, who has access to it. They don't understand when elements of the technology stack are changing. And this can make it very difficult to understand whether something material has changed and whether that has introduced risk into your business. And organizations can often be quite lax in their supplier management and don't realize that, that essentially their assurance argument has become outdated. And then finally, we've got context drift. So this is where the system itself hasn't changed, but its users, its operating conditions, or its purpose have changed. A tool introduced to support one workflow can gradually be sort of migrated to another workflow without anybody realizing, or it can be relied upon more heavily than originally intended. And the assurance case can remain static, whilst actually the real world context has moved around it. And this can cause particular problems in human machine teams, where the way in which a user interacts on the system on day one can be drastically different from how they interact on day 300, and where you're relying heavily on human oversight to catch errors. This change in human behavior can really introduce significant risk. So I think the final thing to say, and then I'll pass back to you, Jed, is that I think the common thread across a lot of the things on this slide here is that assurance isn't a one-off job. It's got to remain connected to those outcomes. It's got to remain connected to system change, to the supply chain change, and the reality of how the AI is actually being used out in the field or out on operations.
Thank you. You've got the life cycle there. I mean, what level of traceability is there? Is that important throughout the life cycle?
So absolutely, and I think Callum will be picking up on that a little bit more. I think in terms of the red flag aspect of it is that if you don't have a structured approach to how you are going to manage your sort of AI assurance case, if you want to call it that, through the life cycle, and how you're going to maintain that sort of traceability, then really you're in an uncontrolled environment, because it's incredibly key. And that's again where risk will start sort of being introduced, not when you know about it and can accept it and understand it, but where you're not even aware of that change.
Thank you.
So the next bit that we wanted to pick up on was this point about then the kind of counterpoint to that, which is what does good assurance look like? And I think it's important throughout this whole section to frame it in two ways. One is that what we're going to describe is the things that need to be in place, and then an example of how we might do it. It's important to note there's lots of different ways to do that, and actually we care much more about that something's in place to manage that challenge than the specific format of how that is done. So the examples are a way of doing things, they're not necessarily the only way of doing things. And the second point is that the reason that this really matters is partly because of the increasing diversity of regulation and standards that are being imposed on most applications. And we had a really strong steer on this from the ICO late last year, which was very clear that the way to solve that problem, the way to solve that regulatory environment is uncertain, you don't know exactly what you're going to have to provide, is by doing the job right to start with. Because actually the formatting and the kind of producing of specific artifacts is becoming more and more trivial over time. What is really hard is making sure that your system is built in a way that it is assurable in the first place, or it's deployed in a constructed environment with the right controls around it, that you are able to produce that assurance evidence. The specific format is becoming much, much easier to produce evidence for different regulatory environments, different countries, etc., etc. So on that point then, I think we have 4 critical elements that we see needing to happen in order to be able to do assurance right. The first one is all about a kind of conceptual methodology. So this doesn't mean that you need to have an exact kind of 25-stage process that you go and tick through every element as you go through. In general, I don't think that sort of process is particularly effective for doing this. But this is about having an understanding about the kind of claims that you're making about that system, what they mean in your specific context and what evidence you're producing. And then crucially, the fact that that pulls together to form an argument. And we use a conceptual methodology that's based off the CAE framework. It's used across industry, particularly in the nuclear industry for safety cases, but it's very relevant for a lot of things. And it's all about how do we understand the links between our systems. So we go from claims to implementation. We use arguments to kind of break those claims down and explain what they mean in our context, what the significance of them is, and how our evidence pulls together. We use measurement to understand more about our implementation, to produce evidence. And then from that evidence, we use justification to show how those claims are true in that environment for that context and for that kind of specific user, or whatever kind of bounds and assumptions you need to make on those claims to make it relevant. Just to illustrate this, we're going to use an example, and I picked an example here of a supermarket or kind of a retail store that's using AI facial recognition to screen and match, kind of known shoplifters or people who've caused behavioural problems. And this is a kind of a very small snapshot of what that sort of assurance argument might look like. Now, this is intentionally incomplete because this would need to be much more extensive to understand some of the nuances of it. But the core of it, we're trying to make that kind of statement, that claim that the alerting is safe enough for controlled use. And to do that, we could make a very simple argument that breaks it down into two elements and says that actually the accuracy is adequate for us, and that the human controls we put in place limit the harm that could happen, even if failure occurs. Now, you need to think very carefully about how you define that adequacy. In particular, it's a real challenge to say that something is adequate. But this allows us to then understand how the evidence down at the bottom, things like in-store validation tests, false match rates, our training logs, escalation checks, might link up to support that argument and ultimately justify those claims. Now, like I said, obviously, you would need a greater number of these claims to cover different aspects of the system. For example, like the quality of the watch list that you're using, the data that's going into that, how you do your privacy controls and manage those data protection elements of it. All of those play into it. But the crucial thing is what this does is it transforms your kind of pile of evidence into a structured argument so that you can make that case that this system is trustworthy. And that, again, supports that point about making it applicable to multiple regulatory environments, making it applicable across multiple legislative settings, is that if you have this argument that makes sense and is a strong, robust argument, then you can pull out the elements of it that are relevant and make those arguments for compliance as well. But if you haven't done this, it can be very difficult to reconstruct that retrospectively. So it's also an activity that needs to be early in the system life cycle. And just on that point about traceability and also on the life cycle point, I've got an example here of how we might talk about that traceability and why it's important. So typically, we can often see it's a core failure mode that we see is people use different teams throughout the whole life cycle. And that also includes across the spread of developers, deployers, and users as well. And that can lead to a lot of fragmentation, how that evidence is collected. And actually, there's often kind of common themes that run through it. So in this case, I pulled out a theme about failure mode analysis or hazard analysis. We need to apply that all the way through our system. So upfront, understanding those early hazards that allows us to design controls into our system to help with them and change the architecture in order to make it more assurable and surface that evidence. We then need to look at the data and look at the failure modes that the data could create. Later on, when we've got a developed system, we might look at some failure injection testing where we start to kind of stress the system and put it in those situations that we identified earlier. And then we also need to ensure that we have that operational monitoring as we go through. And I guess the point to make here is that for each kind of those failure modes that you're looking at, you need to have really clear traceability throughout the whole life cycle of how that failure mode affects the system at different parts of the life cycle, and there are different considerations that you might have in terms of how you solve that. So, for example, earlier on, we might go, okay, there's this risk of false identification. It's a core hazard for this sort of system, and it could have really severe consequences, right? Can you imagine going into every Sainsbury's you go into, and it blocks you from going into that Sainsbury's for, as far as you can tell, no reason whatsoever? It could actually cause a really significant disruption to your life and actually affect your ability to go about your activities of daily living. And so we think about requirements for human review at that stage. But then actually, when we get to the data point and we're looking at those data-related failures, then that might give us a different set of controls, a different set of analysis to do, understanding the ways that the data could cause these failures and what we need to do in order to prevent that. And likewise, following that through the life cycle, understanding that then in operation, we could look at things like how we look at alerts. We could also look at some of the kind of design controls that we could implement there. I'll pick up on that in a couple of minutes as well. The third point was about how we analyze AI behavior, how do we understand the behavior of these systems, and also then how do we intervene in that behavior. I could spend an entire hour or more talking about this specific slide in more detail. So I'm going to save you all that and try and get to the crux of it. I'm going to focus on that ways to intervene. And one of the things that we use to talk about this is this order of precedence. And it's really important because it kind of reverses how a lot of organizations kind of stack their chips in terms of where they invest their resources in solving this problem. It is much, much more efficient, and it is much more robust for us to invest our time and effort and resources into design, architecture, implementation solutions, where we reduce the problem by design. If we leave it down the line and we leave it for these kind of this governance sort of stuff, we leave it for training, we leave it for that sort of thing, that stuff's necessary, but actually we can have far greater impact if we try to design out the problem in the first place. And that's what we talk about, this kind of order of precedence, that actually we should be putting much more weight in terms of that early design, the architecture that we use around it, then the sort of kind of technical controls that we can put in place that bound failure when it does happen and kind of isolate consequence. In a security context, they call this reducing the blast radius. Then we look at our monitoring and our visibility of that system. So we're now assuming that that failure has happened, and actually how do we make that degradation? How do we make that failure visible to us so that we understand that there is a problem with our system? And then only then do we kind of rely on those governance controls. And I guess the analogy to relate this to is the flat pack furniture. So if you go out and buy some furniture from IKEA or whatever, they will purposely design their products so that they are hard to assemble incorrectly. That's a design kind of reducing the problem solution there. They only rely on the fact that people are going to read the manuals as a last resort, because in general, I'll be honest, how many of us have actually read an IKEA assembly manual before trying to build our bookshelf? Because I certainly don't, and we'll carry on trying. But actually, they've designed it to be hard to put together wrong. Because it's much more effective in terms of people using their products correctly. And we need that same sort of approach with AI. So going back to that kind of failure context that we were talking about, just some kind of specific examples of things that you can do. At a design level, we could think about building in kind of no auto action thresholds and things like that. So those face matches can't directly trigger interventions. We don't create things automatically, but actually we require some human review within there. Secondly, the kind of technical control layer, we could have some kind of thresholding and things like that to filter out weak or ambiguous matches so that the operators don't get spammed with fake alerts, but also low confidence matches are pulled out of the system. At a monitoring level, we need to understand and get visibility of where those false alerts happen. And so if you think about in a supermarket context, that might require us building in really robust requirements for the operators to tell the system when it was a correct identification and wasn't a correct identification. Because if you don't have that feedback loop built in from the start, that's going to be really hard to understand if your system's degrading in practice. And then only then do we kind of fall back on those governance mechanisms that allow us to keep on with reviewing that evidence that we created in the monitoring stage so that we understand what we might need to do about it, what kind of additional oversight might we need to put in. So hopefully that's given a bit of a kind of a whistle-stop tour there through that sort of implementation thinking and how you might think about that order of precedence. If you want to, one of the things that you'll have seen pop up on your bar at the minute is a copy of an introduction to our AI Assurance by Design framework. This is something that we're publishing at the moment, and it sets out all of this thinking in a lot more detail, and hopefully goes into a lot more practical detail about how you can actually implement this into your organization, what that looks like in practice. And we can talk a little bit more about that later on if that's interesting to people. And then we come to the final part of the puzzle. So we've talked about the kind of conceptual ideas, we've talked about the traceability, we've talked about our kind of implementation and our analysis of these AI systems. We then need a means to pull it all together. And that means, in principle, kind of 6 key things. We need to be able to manage all of those claims, arguments, evidence, risks. We need to get that traceability. It needs to have that sort of traceability functionality. Versioning, auditing, change control approvals, super important, often neglected. This can get into a real mess if you don't have a really clear way of managing this. And you end up in a really difficult situation where things are baselined at different levels and it all gets very, very confusing. We need to build our risk management processes into that. We need to be able to link to a high variety of different evidence types and accept and acknowledge that evidence can come in a lot of different forms, and that can be really useful to us. So it doesn't all need to be kind of written text and reports, but actually data sets and things like that are evidence in their own right. And we need to be able to export and interchange that. Now, like I said, we're going to talk about the way that we would do it, but actually there's plenty of ways you can do it. And that leads us nicely on to one of the reasons why One Beyond are talking to us today is that we use One Beyond to build this software platform for us. And this is the Sync Assure software platform. Essentially, it is a tool that allows us to build these assurance cases in an effective manner, aligned to workflows with some of that, in particular, that versioning and change control elements really strong, and the auditing and logging as well. Yeah, like I said, you can do this in different ways, but the really important thing is that you have a way of doing this that isn't just a pile of spreadsheets that no one's ever looked at for about 30 years. This has got to be something that is easily accessible by a whole range of different users across your organization, that different people are able to extract the different views that they need to understand the risk and responsibility that they're kind of accountable for. And on that point, I'll pass back to Jed.
No, that's great. Thank you, Callum. It's really insightful. I'm quite keen to learn a little bit more about what to do now. So where should organizations start around improving assurance?
Yeah, so I think so the first thing I'd say with this is that in terms of immediate next steps, take what we've spoken about today in terms of some of those anti-patterns, in terms of some of those red flags, take what we've said in terms of, okay, this is a good way of doing AI assurance. And as Callum said in the handout, there's a lot more information in there for you. And I think the first step is really to take a critical look at your organization and essentially say, okay, well, how many of these traps are we falling into? How much of what it is that we're doing from an assurance perspective looks something like what it is that Callum was just sort of going through there, and really start to assess your organizational maturity when it comes to whether it's developing, acquiring, deploying artificial intelligence. I think the other thing I'd encourage as well in terms of next steps is, and I know it's a trite statement, but don't try and boil the ocean in one go. We've seen a lot of organizations fail where they've tried to, look at, the NIST AI risk management framework, for example, and said, right, that's the solution for us. Let's adopt it sort of wholesale. One of the things with AI assurance is that it's very specific to your context. It's very specific to your applications, and you can waste a lot of time, effort, and money in that way. So what I'd really suggest is that if you're interested in improving your posture, look at a thin slice of your organization, look at what it is that you're doing in terms of a particular project, in terms of a particular product, and look from top to bottom. Is that right? Have we really understand what we mean by trustworthiness and what that is made up of? Okay, if we've understood those objectives, how are we flowing that down in terms of the functions the system needs to perform, in terms of the things we need to say about it, the metrics we need to hit, the performance that it needs to achieve? And then all the way down to how are we collecting and then linking the evidence? And think about that just as a thin slice all the way sort of down your organization, and then build out from there is what I would say. I think the other sort of final thing I would say on that is that there is help out there. myself, Callum, Synoptix, we operate in this domain. And I think one of the key things I'd say here as well, which we didn't introduce up top, is that we are AI developers, as well as offering AI assurance and assurance by design as a service, is that we aren't interested in applying sort of a rote checkbox approach to this, which is one size fits all. We understand what this means when the rubber hits the road when developing and deploying AI systems. So with that in mind, we've got a number of ways in which we can work with clients. We're more than happy to have a more in-depth conversation about your particular application offline, but we can do everything from rapid assurance reviews. So, okay, we'll come in, we'll do a relatively small amount of work to find those evidence gaps, to understand where the weak claims live, untested assumptions, and so on. We can run AI assurance workshops to start upskilling teams, to start developing how it is you're doing AI assurance in your organizations. And we can go all the way to embedded assurance support. So we'll work alongside your teams in order to deliver assurance by design, in order to deliver that sort of assurable system out of the end, and the evidence that goes into making that claim that we can trust this system. So as I said, we're more than happy to have a more in-depth conversation. In terms of a question that was asked in terms of where else can we go to read more, I think Dan's answered Stephen's question in the chat. We do have the handout. There is going to be a more in-depth description of our assurance by design process or framework that we can make available. And also there is various publications and blogs that are put out through our website and LinkedIn as well, which will hopefully illuminate you on some of the issues. Callum, anything to add on that?
Nothing from me other than it's great to get through some of the issues. One thing I want to end on is that sometimes it can feel a little bit like the way that we're presenting things. This is something that is very, very different. This is very kind of uncommon, particularly for people from a kind of strong GRC background. This can be a bit of a different way of doing things. I think the important thing that we always try to come back to is that all of that work is necessary but not sufficient. And that's a kind of core part of our tenet, is that this isn't kind of throwing the baby out with the bathwater and starting again from scratch. This is more about how do we take all of this stuff that we do already and make it and tie it together with that core of argument to make it a real useful thing for our business, and in particular how we can enable us to do that over a period of time in the whole life cycle operation of a system. So yeah, I think it's just important to kind of come back to.
Great, thank you, Callum. I can see there's some more questions populating in the chat roll here. And again, I just want to say thank you to you both, but also thank you to the audience for filling out the polls, questions that have been coming through. But let's tackle some of the questions that are going on in chat here. We've got one from Warren. Really interesting talk, thank you. One thing I'm curious about is where you draw the line between using AI and using conventional deterministic software. So your face rec example works well because the AI is only generating an alert, and the operator makes a decision. Who would like to handle this question? Sam?
Yeah, I'll have the first punt at it. So I think we often talk about AI assurance, trustworthy sort of AI, and one of the natural questions, which Warren's question sort of rotates around, is, well, what do we mean about AI in this context? And what we don't mean is sort of the textbook sort of ISO definition. You know, it's some sort of computer system that sort of performs a function which usually requires human intelligence, perception, reasoning, learning, things like that. That's a broad church. What we're really talking about here is largely machine learning, particularly deep learning, neural networks. And we mean that really for three reasons. Is that firstly, the power of that technology has meant that they're being put to uses which are complex, which are big, which have incredibly complex input spaces, and that consequently, because they are quite capable, the impact of them going wrong can often be sort of quite severe. The second reason is that a lot of our traditional approaches to testing things falls over at that point. There's no real code to inspect a lot of the time. A lot of the time it's black box. Yes, there's things you can do with it in terms of explainability and interpretability, but it is very difficult to deploy our traditional test regimes. For example, we are used to be able to test 1 point here, 1 point here, let's say in aerodynamics, and then be able to infer what happens between those 2 points. That disappears when it comes to AI. It's when it comes to deep learning, sorry, and neural networks. And finally, it's because they behave in odd ways, and they fail in odd ways. You know, things like hallucinations, which we're all aware of, but even things like a very minor input, let's say on a computer vision system, a very minor input, change to the input, perturbation, can result in drastically different outputs. They fail in ways that are different to standard conventional sort of software. So I think, like I said, that's a very long answer to the, we largely mean deep learning and, you know, neural networks, particularly large complex ones. But effectively, that's the reason why these are the things we care about.
Great, thank you for that, Sam. And again, I'd just like to encourage some of our audience members. If you do have a question, feel free to pop it into the chat, and we'll read those out for you. And just while people are typing questions in, is there anything else that you would like to add, Sam or Callum?
I just wanted to pick up on this point about sometimes about the kind of the difference between the conventional software and the AI as well. And actually, quite often times the approach that we adopt in terms of the design of those systems is to use a blend of the different approaches. You know, just because all of those things that Sam was speaking about kind of the deep learning exist, that doesn't mean that kind of, for example, conventional computer vision techniques or conventional signal processing techniques went away overnight. So actually, some of the most effective approaches that we've seen and what we develop in some of our own AI products is by using a blend of different approaches, and that can be really powerful. That can also help build that assurance case for you, because you're not just trying to purely argue about a black box, but you actually have layers of architecture or layers of more conventional techniques around it as well, and that can be quite helpful when you're trying to make these arguments.
Great, thank you. And back to the audience again. And does anyone else have any questions that they would like to ask Sam and Callum whilst we have them here? That's fine. We can always reach out, and we can do questions and answers via email as well. Oh, hang on. It sounds like we've got a question here from Stephen. Could you expand on your experience of governance drift and agentic drift and how they intersect?
You cover that one, Callum. You're on mute, Callum. Callum. All right, I'm not sure Callum's microphone is working at this point. We can get back to you with an answer on that one. Apologies, it's not something I'm best placed to answer.
That's fine. But again, if there are any other questions, we can come back to you on. But just before we wrap up the call, if anyone does have any further questions, please do pop them in the chat, and we'll make sure that we get back to all of these. Okay, we've got one from Simon. Have you come across any successful deployments where uncertainty around predictions has been modeled and then used to either pass on to the user or use it as a threshold to allow the model to say, don't know?
Yes, I'll cover this partly because I think we've lost Callum there. So the simple is yes, but partially. Whenever we're talking about predictions of uncertainty coming out of neural networks, things like confidence scores and things like that, you need to be very, very careful in their interpretation. So the standard, again, we all are most familiar with things like computer vision systems, boxes on screens. The confidence scores there, for example, that they're providing, that is nothing to do when it says it's a car. That is not an objective confidence score where it is 73% confident it is a car. It is some measure of how much what it's seeing at the moment matches its data training, its training data sort of corpus that's been sort of fed into it. Now, that doesn't mean that there aren't things that you can do in order to make those confidence figures and make those measures of uncertainties useful. You just need to be very, very careful in terms of how they are interpreted. And actually, we do have some technology which is subject to a patent which tries to get those types of confidence scores closer to an actual determination of real uncertainty. The other thing I would say, though, and this is where actually the development of a system can really get you a get out of jail free card, is if you just try to do this, you've got a neural network, it's going to give you some sort of uncertainty metric or confidence score. And and you're going to do something with that information. It's tough, it's tricky, you're dealing with some fundamental mathematical constraints in neural networks. However, with intelligent design of the system, though, you can do things. So, for example, you could have a neural network which is doing classification, but you can also have a neural network which is just doing anomaly detection. So again, in the computer vision example, one neural network is saying, I think this is a car. Another neural network is saying, do I think there's something out there? And you can start to add additional channels in, essentially, in order to make a determination of certainty in there being an object there and what the classification is. And as Callum said as well, you can also use sort of classical techniques. So I'd say that the most effective way of dealing with this is looking at a system rather than looking at this. Let's try to deal with how neural networks work. The best way is to accept that neural networks aren't very good at really objectively determining uncertainty, and you try to deal with that more widely. In terms of specific experiences and successful deployments, yes, we've got particular experience with some computer vision products we're actually developing for maritime autonomy, where we're working with the Royal Navy, for example, on that. So sorry, that was probably quite a long answer to a deceptively simple question.
No, that was fantastic. Thank you, Sam. And Callum, welcome back. Should we
Yes,
can tackle Stephen's questions around the governance drift and agentic drift?
Yeah, absolutely. Apologies. My computer decided I wasn't going to let me click the button to unmute, which was exceptionally helpful. Yeah, and I think agentic drift in particular is a really interesting one because there's a number of different problems that are intersecting here. So part of the challenges I think around this are that sometimes we're treating the agentic concepts as somehow separate from a lot of the experience of managing autonomous systems in the first case, because fundamentally the kind of concept of agentic systems, a lot of it aligns with a lot of the challenges in the autonomous environment. So understanding that liability, I think there's some separate technical challenges in there, particularly around, for example, handoffs between separate agents within a system, and I think a lot of that comes back to how do you manage very carefully the input and output spaces of all of those parts of that chain, and understanding really what they're doing as part of an overall process, rather than just trying to kind of, I guess, whack some LLMs in there and see what happens, which appears to be quite a common approach in a lot of frontier model development at the minute. So I think going back to that point about those that implementation hierarchy, really carefully designing that system and architecting that system so you understand what is being managed, what decisions are being delegated, and what the significance of those individual parts of the system, if they go wrong, what significance that will bring on the overall outcomes the system creates, I think is really important in terms of that side of things. And our existing governance frameworks often aren't built to do that in any way whatsoever. So I think there's a lot of challenges as businesses start to adopt some of the more agentic things, that they need to think much more deeply about what the actual kind of decision-making framework is, what the actual kind of accountability framework is that includes the agentic systems as part of that, and how that affects on ways of working, and it will lead to changes to how people work. It will lead to kind of knock-on implications of people's jobs and things like that in terms of what they're actually responsible for and accountable for. And we can't just kind of necessarily copy and paste that between systems that have autonomy as part of them and systems that don't.
Superb. Thank you, Callum. Thank you. Do we have any other questions? Let me have a look at the chat. One from Kyle. What would you class as a high stakes case when implementing? Is this complexity, financial risk, population reach, or health?
So typically we talk about high stakes as having three elements to it. So it needs to have severe consequences of some kind. So that could be financial, that could be hazards to kind of physical safety, that could be reputational risk, whatever, some kind of severe consequences, things you really don't want to happen. The second part is generally some sort of risk factor that makes things harder. And that's because there can be a number of different elements there. The typical ones that we see, the two biggest ones, are a high level of uncertainty about the decisions that are available to the system. So for example, the example I always give is if you're a circuit breaker within a kind of a high voltage distribution system, really matters, can have a lot of consequence if it goes wrong. But actually, there's only two options available to it. It's either open or closed. If you then expand that to looking at the control of a huge number of circuit breakers across a distributed electrical system, that then the kind of introduces a whole lot of uncertainty about the possible state of that system and what state it can be and what implications that will have. So the uncertainty really matters. The second one in that category really is time sensitivity as well. A lot of the time what we see, particularly around more autonomous systems, is they're moving at machine speed, and try as you like, there is no way that a human can look at all of the outputs of the system. That's just simply not possible. The human has to be looking at some level of some abstraction, and how you design that abstraction and how you ensure that it represents all of the things that are relevant about what the machine is doing, but actually simplifies it to an abstraction that a human is actually available to comprehend. That's a real art to designing that sort of control system. And then the third bit is about reversibility, and specifically non-reversibility. So that our high stakes definition includes, once a decision is made, once an action is taken, it'll be very hard to reverse the consequences of that within the system. And what we typically find with those high stakes systems is there's this kind of band of applications and contexts that sit below kind of traditional safety critical systems, but also above the kind of mass markets, business to consumer or business to business systems that are very familiar to all of us. And one of the things that AI is also creating in terms of people's ability to develop new systems is, because of the increased pace that AI-assisted development and particularly AI-assisted programming gives you, many more systems are falling into that category, that high stakes band, because people are able to explore those applications, and particularly they're able to explore them with, in often cases, much smaller teams, maybe outside of the existing constructs of organizations as well. And that brings a whole new set of challenges to there as well.
That's great. Thank you, Helen. Any other questions from our audience members? Okay, I have a question. How would you go about balancing speed versus insurance?
So I think the first thing to say, and the most fundamental, is I would say don't treat it as a bolt-on at the end. This is true for any form of assurance, but for some reason, when it comes to AI, this tends to be neglected. You know, if you put it into another domain, if you were designing a passenger jet, for example, and you left your safety assurance to the end, and you weren't doing anything progressively in terms of the design decisions you were making, in terms of the evidence you were generating, and imagine how badly wrong that program would go. That's quite tangible. That's quite sort of something that people can understand. You then transpose that into the AI domain, and somehow we have this different view. Is actually, in order to do pace, we've got to do all this development, and then we'll try to bolt assurance activities onto the end. So the most fundamental decision is to treat this as a life cycle issue and get it in early. That's how you enable the innovation. That's how you enable the pace. I think the other thing that I would say about that as well, as a sort of a related but equally important issue, is that it gives you breakpoints. We've seen a number of what on face value will look like quite innovative applications of AI, which effectively they have no route to assurance, but in the interest of pace, they haven't really considered the assurance things. They've driven down the sort of the pace route, and they're essentially 3 years into a development for something that they can't do that last 10%. They can't get to the assured position in order to get to market. So as I said, that's, to me, that's the most fundamental way in which you can improve pace. Callum, anything to add to that?
Yeah, I think the only thing I'd say as well is that, and is perhaps a good message to leave on, is we often talk around assurance as somehow being a blocker or a barrier to innovation, and it stops you, it slows you down, it says no to things. One of the ways that we try and reframe it is that assurance is the way that allows us to say yes. This is the thing that gives us that confidence to actually explore applications that we couldn't even think about before because they were too risky, they had a kind of too high a consequence attached to them. And I think when we reframe it around that, it becomes a much more positive way and actually improves the overall speed of delivery, because it also improves the capability of what we're able to deliver at the end. And it means there's less rework required with pulling that back away from the front line, reworking things and getting it back in the hands of users. So that's very much how we see assurance, and it's really important that we don't kind of allow ourselves to get sucked into this narrative that this is somehow a bad thing and doing assurance right is a bad thing. It can be a really kind of pro-innovation move that can really strengthen your position within the market as well.
Fantastic, thank you, Callum. Well, look, I mean, we've come to time now, so we'll wrap things up. Thank you again for both Sam and Callum's vital input in today's conversation, and also for the questions that came and the polls that were filled out by our audience members. The session has been recorded. We'll make sure this gets sent out to everybody, and I'm sure that there'll be contact throughout the coming weeks. So if you do have any further questions, by all means, please do send them over to us. We'll have someone contact you and reach out to see if there's any other further questions that you have for the gentleman. But other than that, thank you very much for everyone attending today's session, and yeah, we hopefully look forward to seeing you again in future webinars.
Thank you.
Thank you. Have a good day.